Now we will do problem based on, that is the addition formula of tan and cot and sin and cos functions. So the first problem is, it is very important problem, just do it carefully. If sin alpha is equal to 4 by 5 and alpha is lying in third quadrant, that is pi by 2 to pi, that is in second quadrant, and tan beta, which is equal to minus 12 over 5, that is minus pi by 2 less than beta less than 0, that is in fourth quadrant. Now you will think, how can we say that? As 0 to pi by 2 is lying in first quadrant, and by taking the mirror image of 0 to pi by 2, we get fourth quadrant. So it's lying in fourth quadrant. Then we have to determine the quadrant of P of alpha plus beta and P of alpha minus beta. So first of all, we will find in which quadrant alpha and beta lie. So as we have pi by 2 less than alpha less than pi and beta, that is minus pi by 2 to 0. So on adding these inequality, we get 0 less than alpha plus beta less than pi, that is 0 to pi, that is in first or second quadrant. So that is P of alpha plus beta may be lie in first or second quadrant. So in first quadrant, sin is positive and tan is also positive. Sorry, not here the use of tan, that is cos. As the coordinate of P of alpha beta is cos alpha plus beta and sin alpha plus beta. And in second quadrant, sin is positive and cos is negative. So there is a variation of change in sign of cos from first to second quadrant. So we will get that where it is lie, alpha plus beta lie, that will be determined by finding the sign of cos alpha plus beta. So to determine the quadrant of P of alpha plus beta, as we have cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Give its name as number 1. So as sin alpha is equal to 4 over 5 and it is lying it between second quadrant, therefore cos alpha will be negative, that is negative of, using the identity, under root 1 minus sin square alpha. So substitute here the value of sin alpha, that is 16 over 25, that is sin square alpha. So we get cos alpha is equal to negative of under root 9 over 25, that is minus 3 over 5. And also tan beta is equal to minus 12 over 5 and lying in fourth quadrant. Now we have to find the value of cos as well as sin beta. So there is a relation between tan and secant. By finding the value of secant, we can find the value of cos. So in fourth quadrant, secant beta is positive. It becomes under root 1 plus tan square beta. So we get 1 plus 144 over 25. That is under root 169 over 25. So we get secant beta is equal to 13 over 5. Therefore, cos beta becomes 5 over 13. So as in fourth quadrant sine is negative, we get sin beta is equal to negative of 1 minus cos square beta. That is negative of 1 minus 25 over 169. So that is we get minus of under root 144 over 169, that is minus of 12 over 13. So we get sin alpha, sin beta, cos beta. Therefore from number 1, we have cos alpha plus beta is equal to, by substituting all the values, minus 3 over 5 into 5 over 13 minus 4 over 5 into minus 12 over 13. So we get minus 15 over 65 plus 48 over 65. That is 32 over 65, that is greater than 0, as cos is positive. As cos alpha plus beta is greater than 0, that is P of alpha plus beta lies in first quadrant. Now we have to find the quadrant of P of alpha minus beta. Now to find the quadrant of P of alpha minus beta, we will proceed in the same manner to find the quadrant of any point. So as pi by 2 less than alpha less than pi and minus pi by 2 less than beta less than 0 implies on multiplying by minus 1 we have to find the value of minus beta. We will get pi by 2 greater than minus beta greater than 0. That is 0 less than minus beta less than pi by 2. So on adding, we will get pi by 2 less than alpha minus beta less than 3 pi by 2. So as alpha minus beta lie in either second or third quadrant. So in second quadrant, sin is positive and cos is negative. And in third quadrant, sin is negative and cos is negative. So there is variation in the sign of sine trigonometric function. So quadrant of P of alpha minus beta will be decided with the help of sine of alpha minus beta. So sine of alpha minus beta is equal to sine alpha cos beta plus cos alpha sin beta. So by substituting the value, as we know all the values, that is 4 by 5, cos beta is 5 over 13, because by taking the negative or positive sign, sin is positive, cos is positive, cos is negative, and we get 5 of 13 plus cos alpha is, so here sin alpha minus beta, take the sign minus alpha, and cos alpha is minus 3 over 5 and minus 12 over 13. As we have already done, that is where alpha and beta lie. So we get 20 over 65 minus 36 over 65. So we get minus 16 over 65, that is less than 0. That is sign is negative. Therefore, P of alpha minus beta lies in third quadrant. So by using this concept, we can find the position of any function, that is P of alpha plus beta and P of alpha minus beta, that is any angle, if we know alpha and beta. Now the next problem is, find the range of cos theta plus sine of theta plus pi over 3. So as we done the topic, that is range of f alpha. So let f of theta is equal to cos theta plus sine theta plus pi by 3. So we have to convert first of all this into a cos theta plus b sine theta. So we will open the formula of sine a plus b, that is sine a cos b plus cos a sine b. So as we know the value of cos pi by 3, that is half, and sine, that is sine pi by 3, that is under root 3 by 2 into cos theta. So we get the value, that is 1 minus under root 3 over 2 cos theta plus half sine theta. So now compare with a cos theta plus b sine theta. We will get r is equal to a square plus b square, r square, that is 1 plus under root 3 over 2 whole square plus b square, that is half square. So we will get a square plus b square plus 2ab plus b square. So we get 2 plus 2 root 3, that is 2 outside, 1 plus root 3. So we get r is equal to under root 2 into 1 plus under root 3. Now the range of r is, therefore range of f is minus r to r, that is minus under root 2 plus 1 under root 3 to under root 2 plus 1 under root 3. So this is the range of this function. So we can find the range of so many functions. Now the next problem is, determine whether sine 120 degree plus cos 120 degree is positive or negative. We have already done such type of question. This is another method, an easy method to solve such type of question. Let f of theta here sine 120 degree plus cos 120 degree. So here a is 1 and b is 1. So multiply and divide by under root a square plus b square, that is under root 2. So we get 1 over root 2 sine 120 degree plus 1 over under root 2 cos 120 degree. So we get cos 45 degree into sine 120 degree plus sine 45 degree into cos 120 degree. So we get cos A sin B and cos B sin A. Sin A cos B cos B, sin A cos B and cos A sin B. So this is the formula of sin A plus B, that is 120 degree plus 45 degree. So we get under root sin 165 degree, as sin 165 degree lie in second quadrant. Therefore, sin 165 degree greater than 0, that is positive. And root 2 is always greater than 0, that is positive. Therefore, product of two positive function is positive. So as f of theta is the product of two positive function, that is root 2 and sin 165 degree, therefore f of theta is positive, that is greater than 0. So f of theta is positive, being the product of two positive functions. Now the next problem is, if under root 3 cos alpha minus sin alpha is equal to r times cos alpha minus theta, find r and theta where r is greater than 0. For the case when theta lying between 0 to 2 pi and when theta lying between minus pi by 2 to 0. So, the solution is, let f of alpha is equal to under root 3 cos alpha minus sin alpha. So, on comparing, here a is equal to under root 3, b is equal to minus 1. Therefore, r is equal to under root a square, that is 3, and b square, that is 1, that is under root 4. So we get that is 2 and 2 is greater than 0. Therefore, f of alpha is 2 divided by 2. So we get, as we done in the previous question, so we get the form under root 3 by 2 is cos pi by 6, that is our wish to convert into cos formula or sin formula, and half is sin pi by 6 into sin alpha. So we get 2 times cos alpha plus pi by 6, that is cos alpha plus beta. So we can rewrite as 2 cos alpha minus theta form, that is minus this. Here we convert in cos because that is a demand of our question. So here we can compare with the given equation, r is equal to 2 and theta is equal to minus pi by 6, that is negative and lying between minus pi by 2 less than theta less than 0. So for this range, value of theta is minus pi by 6 and r is 2. R is equal to 2 for the same, remain the same for these two cases. Now we have to find the value of theta for 0 to 2. Now we have 2 cos alpha plus pi over 6, that can be written as it is a periodic function of 2 pi, so we can rewrite as cos 2 pi minus theta or 2 pi plus theta. And as we have to 0 to 2 pi, so we will take 2 pi minus theta. So we will get cos 2 pi minus alpha minus pi by 6. So we will get 2 times cos 2 pi minus pi by 6 is 11 pi over 6 minus alpha. We have to form the form r cos alpha minus theta. So minus is common out, we get alpha minus 11 pi over 6. So we get cos of minus theta is cos theta, that is cos alpha minus 11 pi over 6. So on comparing, we get theta is equal to 11 pi over 6, that is lying between 0 to 2 pi. So we get for 0 to 2 pi, theta is 11 pi by 6, and for minus pi by 2 to 0, theta is equal to minus pi over 6. So this completes our result.